Hello friends, welcome to my channel. Let's have a look at problem 146, least recently used cache. So in this video, we're going to give a implementation of this LRU cache using ordered dictionary. So first, I'll read through the statement of the problem to digest the requirement, and then we do a simple analysis, and then finally we share the code. So this problem is that we are required to design a data structure that follows the constraints of a least recently used cache. So we are going to implement the LRU cache class, which contains a initializer and a get method and a put method. So the functions get and put must each run in O1 average time complexity. So here are one examples. So here are the explanations. So we're not going to go into the details for this example. So before we look at the analysis, let's first look at the constraints. So first, the capacity is kept at 3000, and the key is in between 0 and 10 to the power 4, and the value is in between 0 and 10 to the power 5. And here is an upper bound for the number of operations or calls to invoke get and put methods. So that's the problem. So actually, this problem is a little bit different from the typical ones. So this here we are required to implement a class with specified method, but this is still our routine in some sense. So here in this video, we are going to share an implementation with the help of ordered dictionary. So here our goals are the following. First, we are going to practice the use of ordered container. So here ordered dictionary. And secondly, so we are going to review several cache replacement policies. So notice that typically or usually for LRU cache implementation, so two underlying abstract data types come into play. So one is a hash map or dictionary. So this is to play the role of associating key with cache entry. And another one is a doubly linked list. So this is to track when each entry were last accessed. So here in this video, we are going to use ordered dictionary. So an ordered container. So actually, this container has the above two functionalities. So this is the second item. So the third part is that it's basically extra. So here we are going to list several cache replacement or eviction policies. So least recently used cache is the one among the many cache replacement policies. So the LRU is actually a very routine or very popular one. Some common ones are the following. Let's see the least recently used cache, so the least frequently used cache, and the MRU, the most recently used, and also the FIFO, so first in, first out, so which is like queue. So LIFO, so last in, first out, which is like a stack. So another one which is simple but sometimes can be used is the random one. So randomly select a cache entry to discard. So these are the cache replacement policies. So actually it's good to practice implement all of this. So with that said, let's look at the implementation. So if we use the ordered dictionary, so the implementation actually is very straightforward. So for the initialization, first we're going to have any cache will have a capacity. So typically for a cache, which will have a set smaller than the database, because the purpose of a cache is to reduce the latency of a request and also share some traffic of the database or the server. So the self capacity, so we'll see is capacity, and the self. So we're going to introduce another attribute. Let's call it cache. So this will be the ordered dictionary. So ordered dict. So because we use this, let's first let's actually do this collections ordered dictionary, OrderedDict. So that's the initialization. So next, let's look at the get method. So first, I'm going to consider the cache miss case. So if key not in self cache. So in this case, it corresponds to a cache miss. So we are going to return -1 as required by the problem. So the other case is a cache hit. So in the case of hash hit, so we're going to get the value. So the value will be self cache key, and then we are going to dial this one first. So dial self cache. So the reason we dial this one because we need to insert in the very last, because this one, so this entry is last accessed. So we're going to add this self cache. So we're going to add this key to this value. Then we're going to return the value. So this is the get method. So here we consider two cases. First is a cache miss, so we're going to return -1. And then for the cache hit case, we're going to return the corresponding value for sure. However, we need to pay attention to the time the cache entry was accessed. So that's the operation here. First dial, and then add to the very last. So this is the get method. Now let's look at the put method. So for the put method, first I'll check if the key is in self cache. If this is the case, so we're going to first dial it. Dial self cache. Okay. So this operation is again for the sake of order, right? So when the entry was accessed or operated on. So then we're going to do this cache key value. So this corresponding to here, right? Similar. And next, so we're going to consider the cache eviction policy. So here is the least recently used. So for this, we're going to check if the length of self cache is greater than self capacity. So in this case, so we're going to pop the oldest one. So it's cache pop atom. So in this case, we're going to set last equals false, because we want to pop the one that is least recently used due to the policy requirement. So with that said, I guess that's a full implementation of the LRU cache. So first, let's do a special case check. It might be good. Yeah, it passes one example. Now let's look at generic case. Yeah, it passes all the cases. I guess for this specific problem or implementation, that's about it. So here, our purpose, as we stated before, is to practice the use of ordered dictionary in Python. And secondly, we reviewed some of the common cache eviction policies. So with that said, I guess that's about it for this video. Thank you very much.